Welcome everyone who is live and watching this later for another free Integration Quest study group. Thank you for joining us today. Today we have Ryan. He's going to be presenting on DataWeave Puzzles. He's going to be going through some advent of code. We're going to be following along with him as we go through live and looking forward to it. Learning DataWeave, my favorite. Let's go over a couple things before I turn it over to them. So just like we've all been doing, everybody's been great. If your mom and dad would have recommended you not do it, please don't do it. And we'll carry on. It's been had a great track record. All right. So I'd just like to let everybody know, if you're watching this archived and you're on YouTube, you don't need to know this. But for the people that are live, we've got these two links where you can go get on our YouTube channel and check out the library. We got all sorts of information out there. I recommend subscribing while you're there and hitting that bell and getting these notifications that we are giving more information for you. Ryan has been doing this for quite a while. Like I always say, it's not just about the experience and everything that he is bringing to the table. It's the fact that he's willing to help us and share with us. So thank you so much for doing that. Thank you for coming out here today and presenting on DataWeave. I'm going to stop sharing so that way he can go ahead and run us through this. And I'll just keep an eye on the chat. If there's any questions or anything, feel free to ask anybody, and I will catch those questions. All right.
All right. Well, thanks for the intro, RJ. I noticed we got Philip here in the live studio audience. He and I were talking about Advent of Code because it's well, I think there's some things in software that you don't learn by watching videos. There's things you gotta do them. It's like you can't learn karate from watching videos. You have to go get on a mat and punch people and dodge, right? I mean, there's a practice to it. And so I've always valued hands-on challenges. Integration Quest was started partly out of our Diana and my conviction that people learn better by doing things themselves, right? So we've always tried to find more ways to have you do things you want to learn hands-on, right? So programming is a lot like that, and I really am appreciative to Advent of Code, the creator. I'm going to do a little presentation about what it is. I started doing it a few years ago, but it's been around for about 10 years. We're going to use DataWeave to do it, and you're going to hopefully get a little more. I always got a lot more appreciation for the how useful the DataWeave language is by doing these puzzles. So I started doing them a couple of years ago in DataWeave with me and Alex Martinez did it on Twitch a couple of times, and then she got ahead of me, and then I got ahead of her. So it's certainly been a little bit of a MuleSoft community tradition. So Advent of Code is free. It's a challenge that comes out every year in the month of December, kind of designed on an Advent calendar metaphor, right? Which is coding puzzles. And you get your own input, which is very much in line with how Integration Quest wants to do our education, where everybody gets their own challenge. And so you have to solve the problem with code and then put your solution in. And what that does is it gives people in all different languages a way to practice doing programming, solving programming problems, practice the way of thinking about solving programming problems. So each day a puzzle comes out at midnight Eastern time, starting December 1st. So I was online this year, November 30th. I stayed up late, and at midnight or at 11 o'clock Central, I live in Central time, the puzzle came out, and it suddenly shows up on your screen. So each day the puzzles are released, and everybody gets access to the puzzle at the same time. So that you can try to solve the puzzle every year. But all the old year's puzzles are still there. So not only are there puzzles each day of December, you can always go back to the old years and see what those puzzles are. The way the puzzle works is you get some kind of a sample input and a description in English of what the challenge is, and you have to provide the answer. That's it. So you do whatever you want to get the answer, but it's going to take code to do it. And you could use any programming language you want. So people are very creative about all different programming languages. I started using DataWeave in 2023 to do it, or maybe I did 22. I think it was 23 because I did Go the year before that. So it gives you kind of people can kind of flex their favorite programming language with Advent of Code. In 2025, the puzzles have changed. So this year, starting in December, our puzzles are now a little different. We only get 12 days, so no more puzzles are coming out. It's already the 19th. All the puzzles for 2025 are already published. I am not finished with all of them, but I'm close. I'm into day 10. And so that's partly because the creator has to do a lot of work to make puzzles, and it doesn't, he just does it on donations. You can sponsor Advent I did. It'll show it on your profile that you're a sponsor for any amount you want to sponsor. You can do $1 and get a sponsorship on your profile. And then, but I did more than that, but you can, but there's only 12 puzzles this year. And all the previous years had 25 puzzles that came out until Christmas Eve. Also, there's no more global leaderboard. Every year up to now, there was a global leaderboard, and what that did was it had people, up in the middle of the night, trying to be on the top 100 in the world, and a lot of people did. One of our local guys in Oklahoma, Nick Gavalas, was a contender for the global leaderboard. But this year, there is no global leaderboard. There's only private leaderboards. So if you want to compete with people, which you can, you just use your own private leaderboard. And at the end of this video, you can have my private leaderboard code and get on mine. So because I like the competitive side of it, and I like seeing how far along everybody is, but there's no global leaderboard anymore in 2025. So in today's session, we're going to take some older data we have never seen before. So it'll be fun. We'll be tackling them fresh together with the DataWeave language. I thought that'd be a fun way to get into some modern DataWeave tools. I just didn't happen to look at a few years. 2016, 17, 18, 19, some older ones, and we'll see what they have in them. And you guys, this is unlike I've ever done before. I've always done Advent of Code puzzles myself alone, but you guys are welcome to help me in the session if you're here. So Manikanta and Philip and RJ, I'm glad you guys are here. We can work on it together. I'll do it, but I mean, I'm happy to take, this will be a mob programming session instead of a solo presentation. Ideas are welcome. We can solve together. All right, so here's the way an Advent of Code puzzle works. You're going to have to parse some kind of input that you got from the Advent of Code site. I'm going to show you what that looks like. And DataWeave is really good at the parsing input, isn't it? Right? And then you have to somehow write an algorithm to solve whatever part one of the day's puzzle is. Now, each day has 2 parts, so don't give up after part 1. I'm looking at you, Philip. He forgot. He didn't notice that when he started. It's an easy thing that when you finish the part 1 puzzle, part 2 opens up underneath it, and then you can solve part 2, modifying the solution for environments in part 2 of the puzzle. So they're a lot of fun that way. And you don't get to know what part 2 is until after you solve part 1 of the puzzle. So we're going to use DataWeave. I've been doing this year's in C. DataWeave is so much better for text parsing than C. It's going to be a dream to parse the input, which is not even the hard part of the puzzle. It's just hard in C and super easy in DataWeave. So we're going to have an easy time parsing our input text in DataWeave and getting to the meat of the trouble. And then we got to implement the logic as a transformation. Now, since DataWeave is pure functional, that means sometimes your algorithms have to be modified to be implemented in a functional way instead of in a procedural way. You don't get mutable variables, for example. You don't get global variables, so you can't. So you have to find some way to do it. Ends up usually having things with recursion and lambdas, and we'll probably get stuff. So DataWeave solutions to Advent of Code puzzles are generally going to be very functionally styled programs. So we're going to get to do that. I'm going to do it in Anypoint Code Builder. I think it's the best DataWeave editing experience there is. Anypoint Code Builder in Visual Studio Code, which is free, and you download it and put the extensions in. I have a VM set up ready to go for this. It runs the DataWeave locally, which is better than the playground. I know all you DataWeave folks love the playground, but the playground, especially with Advent of Code, is not going to cut it because it's got limited execution time, limited RAM. So we're going to have to do locally anyway. It's only their only options are VS Code or DataWeave command line, and I like VS Code. So, and then you can quickly iterate on your solution by hitting preview. So that's what we're going to do. I'm going to show you how I set up my DataWeave projects for Advent of Code. So I give a dedicated folder for each day of the year. So I made a GitHub repo for the whole year, and then I put a folder for day 1, a folder for day 2. That way, as the days come out, I can, or as I tackle the days, I'm creating code incrementally, but it's separate from each other. And if I want any shared stuff, I can put it in the parent folder. So we're gonna just do this loop. I'm not even gonna present anymore with slides. We'll just get in and do it, right? So let me show you Advent of Code now. This is Advent of Code, and what I decided I would do first is I kind of made a little randomizer. I looked over all of the years. So you go to the Advent of Code website, first of all, and you sign in. You see this up here? So that's you. And if you're not signed in, you can't solve the puzzles. And then when you go to the calendar, it'll just take you to 2025, and it doesn't seem like there are any more years. So this is 2025. And then all you got to do is change the URL to see previous years. So I went through all the years. It turned out I've already looked at 2015. I started on that. I have no idea what language I did it in. This was probably a long time ago, right? And then I looked in 2016. I didn't have anything, right? So I went through all these. 2019, I still didn't have anything. Let's see. There we go. There's 2019. But this is what you'll see. Everybody will see an empty screen like this. Starting in 2020, I've seen them before. So we're going to restrict today's session to the 4 years I haven't seen, 16, 17, 18, and 19. And so I made a little DataWeave randomizer. Here we go for the years 2016 to 2019. And we're going to pick a random year right now. Here we go. Play. We are doing 2019. See that? So that's how we're going to do it. 2019 is the one that's up, and we are going to look at usually I don't start writing code. Usually I just start by looking at the puzzle. So this is the first time I've ever seen day one of 2019. Here we go. The tyranny of the rocket equation. They're always holiday themed. Santa has become stranded at the edge of the solar system. Oh no. While delivering presents to other planets. I didn't realize Santa was interplanetary. That's very interesting. Yeah, I'll help him. To accurately calculate his position in space, safely align his warp drive, and return to Earth in time to save Christmas. He needs you to bring him measurements from 50 stars. Here we go. Collect stars by solving puzzles. 2 puzzles will be made available each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants a star. Good luck. The elves quickly load you into a spacecraft and prepare to launch. Hello, elves. At the first go, no-go poll, every elf is a go until the fuel counter-upper. They haven't determined the amount of fuel required yet. This is where the puzzle is beginning here. And I usually slow down, and I write my code in the language of the problem because it makes it real easy to trace it back. So there's something called a fuel counter-upper, and there's a Boolean, go, no-go, for elves, right? Fuel required to launch a given module is based on its mass. Specifically, to find the fuel required for a module, take its mass, divide by 3, round down, and subtract 2. It's an algebra problem. So I've got a pencil, and I'm writing m over 3, mass divided by 3, and then I'm going to round it down. I'm going to put round down, or put parentheses around it, and then subtract 2. All right, not too bad. So we've got a little formula we got to apply. So, and then it gives you examples. For a mass of 12, divide by 3, round down to get 4, subtract 2 to get 2. For a mass of 14, dividing by 3 and rounding down still yields 4, so the fuel required is also 2. For a mass of 1969 at 654, the fuel counter-upper needs to know the total fuel requirement. To find it, individually calculate the fuel needed for the mass of each module. Aha. So what we now have is a bunch of modules, 12, 14, 1969, and 100,756. Those are masses. And it's unitless mass, which is interesting. Just some amount of math. So my puzzle input, which in Advent of Code, it's bad manners to share your puzzle input. But I'm hopefully, well, why don't I'm going to be on a video here. So I'm going to take it off the screen. I'm going to hit my button. My puzzle input is, I don't know. It's a bunch of numbers, 5 digits, 6 digits long. Looks like 40 or 50, 60 of them, something like that. So here's how I do that. I'm going to go take these numbers and make a sample input, first of all. And I'm going to do that in a new project. So this is part of what I wanted to show you guys, how I set up. So I've got a VM ready to go, brand new integration quest VM. If you do our classes, hey, where's ARC? If you do our classes, you end up with one of these VMs in class. This goes here. There we go. So here's my Anypoint Code Builder in there. Let's change it to light theme, which works better on videos. There we go. Cool. I've got a Scotty group folder. I'm going to start a new DataWeave project. Okay, so I'm just going to go up here to the command window, DataWeave, create new library project. This is how I do it. Boom. I don't know what all that is. And quest.integration, you could put your business group ID if it was work, but this is not work. This is fun. We're going to call this day 01 is the artifact ID. And I'll just put day 01 again. Then the last question it always asks is what folder. And in Advent of Code, I try to stay organized. So I'm going to put source Advent of Code 2019. And I don't need to put day 01 because when I hit the button, Visual Studio Code is going to append that for me. So if I hit enter, it's going to ask me, what is that? Get out of here. It's going to ask me if I want to open the project in a new window. I usually say yes. And now I'm in day 01. I can minimize the old project, maximize that one, and say I trust. And now I've got a day 1 folder, right? And what I'll do is I'll usually do, until I have a more complicated day, this is a pretty easy day. I'm going to do all the work in source test because you can just run these mappings here, right? A couple of just basic setup things. And I usually, when I'm in real Advent of Code, I do this before the puzzle starts. I do this at like 10:30 p.m. And, so that way when the puzzle comes out, I'm already ready to go. I'm going to take this out and change it to this and get rid of the import and just change that to a 0. There we go. Then under source test resources, I'm going to create a sample.txt and I'm going to create an input.txt. And basically every day I have those two. And then for DataWeave projects, what I'll do is I'll have a git ignore. So I'll add another one, .git ignore, and I'm going to always ignore input.txt. That way it doesn't go on GitHub. What is that? Oh, I keep using the wrong keys because I'm used to Mac. There you go. So input.txt is going to be ignored. What I can do is drop input.txt. Well, I can go to my other screen and put my input in there. So it's not on the video. If we were doing more sophisticated editing, I would just do it on my screen and blur it. But I don't think we're doing that kind of editing. So I've got my input. And I've got this here. Save. And I'll close it and bring it back. There we go. So now the input.txt is loaded. Now the sample is 4 numbers, right? So if we go look at our AOC, it says 12, 14, 1969, and 100,756. So I can't copy paste it, but I could put that in. So I'm just going to put it in. 4. Nope, it's not. It's 12. 12, 14, 1969, and 100,756. There we go. And very simple in a text file. And all I'm going to do now is just make sure I can load it, right? So I'll say var, and I like to use the Advent, and I'll use 2 screens, but since we're in a call together, I will use 1 screen for this. Those are masses, right? No, those are modules, right? The mass of each module. So I'm actually going to model the data sort of like what the problem says. I like to do that myself. So we're going to say modules is equal to read URL. And actually, what I usually do, since I'm showing you what I always do for Advent of Code, this part is usually in a separate var. So var input data is, and I don't use input because that's a reserved word in DataWeave. So I have to use input data is read URL. And I'll use my class path since it's in source test resources, right? Class path And I want sample.text. And then later I can just change that to input.text and see what happens. And so my modules is going to be equal to, and I can import star from strings, right? Lines of input data, map dollar as number. That's probably going to get me pretty close, right? Now I should have 4 numbers, I think, because I just have to do math to them, right? So if I just print out modules, this is so much easier than C. Oh my gosh. Let's see what I get. Unable to find resource sample.text. Oh, I forgot the problem. In the DataWeave library project, you have to have anything that the class path finds has to be in source main resources. I forgot that. So let's move it there, and let's also move our get ignore there. There we go. Source main resources for that. And another little cosmetic thing I usually do, I'll get it running first, is I usually rename this from my mapping. Here we go. What does it say now? 14. Invalid input 1 expected. Oh, I forgot to tell it I'm reading it as. Oh, this is another trick. We're just going to read the whole thing as text plain, right? And so I didn't do that. Sometimes I read it as other. I can use DataWeave. There's a couple of interesting ways to do that. We could do it as application CSV or text plain. One CSV is a little bit easier because it'll do the lines for you. But there it is. Now I have an array of 4 numbers, and basically line 5 I can just keep and use every single day of the competition. It'll be you're going to have a bunch of lines in your input. I don't always put the lines in here because sometimes it's not lines. Sometimes the text is parsed a little differently, like if it's a box or something. But anyway, now I got 4 numbers, right? You guys want to help? Let's do the actual algorithm, right? So I need to divide by 3, round down, and then subtract 2, and then sum them all up at the end, right? So divide by 3, modules, map. Why don't I do this? Mass, and I'm going to get fuel required. I'm going to be a little fancy here. I'm going to make the results of my modules be objects that have mass instead of just numbers. So now I have a bunch of objects that have a mass, and now what I can do is add fuel required to each one, and it'll be pretty. So I like it to be a little pretty. So modules, map, module. So I give it a little lambda here. Module plus plus, and we'll stick the fuel required into it. 0. And run that. Now we have modules with fuel required. And now we just have to do the math, right? So what we'll do is module dot mass over 3 is step 1. Now I have that. And then I need to round it down. In DataWeave, that's a floor, right? So now they're all rounded down. And you see the nice loop here is I can keep hitting preview and just see my output. And in C, that is very much work. I'm having to do all these logs and print lines. So just code change, play, code change, play. It's a really nice tight loop. So now I've got them rounded down, divided by 3. And now we need to subtract 2, right? Let's do it. -2. And then we can check our work. So 12 should give me 2. 12 gives me 2. 14 should give me 2. 14 gives me 2. 1969 should give me 654. Looks like we got that. Fuel required, 33,583. 33,583. All right, so we sum them all up. And what I'll do here is I'll make a little function. Function part 1 for a mod well, before I do part 1, calculate fuel. I'll take that little bit. And now if I'm rushing at 11 p.m., sometimes I don't make my code pretty. Sometimes I just here. If it was actually the night of, I would take this whole thing and then I would do like this. I would put that whole thing in a variable. Var part 1 modules is equal to that. And then I would just do sum of part 1 modules dot fuel required. And I should get 32,241, right? It doesn't tell me that. No, that's low. 34. Oh, it doesn't. Usually it'll give you the part 1 answer for the sample. Anyway, let's just try it for mine. Ready? So I'll just see if I got it. Input.text and run it. And I got this big number here. And paste. Solved. That was fun. 11:30 with a presentation. 30 minutes would not have got me a very high global leaderboard score in 2019. I'll tell you that. They were fast. I wonder if you could even see it. Let's see. Leaderboards. Yeah. So if I go to day 1, this guy did it in 1 minute and 39 seconds. Not bad, right? This was the global leaderboard they used to have. So like, wow. First 100 users to get the first star. Yeah. Are all these guys. I wonder why that's different. Oh, this is the first 100 users who got both stars. That guy took 1 minute 39 to get both stars. 23 seconds to get the... I don't even understand how somebody could solve that in 23 seconds. Something's fishy. Heck, how do you even read it in 23
how do you read and respond?
Well, whatever. I mean, these people are serious. So anyway, but that's why they got rid. I think why they got rid of the global leaderboard. But anyway, that's the global leaderboard they used to have. So now we can continue to part 2. But first, I want to do what I was going to do, which is that I think fuel required should be a function. I was going to do it that way anyway. So let's make it a function. Function fuel required, or yeah, calculate fuel for mass, which is a number, returns a number, is that. And then I'll just pass in mass like that. There we go. Got my function. And now this can be calculate fuel for module.mass. And it'll still give me 3223398. Let's see. Yeah, good. So save, commit. That's what I would normally do. We want to do part 2. What just happened here? Looks like it documented it for me. No, thank you. Control Z. That was a lot. All right, cool. Now what's it saying? Oh, because I don't... What's it mad about? Expecting array a number, but got null. Oh, okay, fine. There. It still ran anyway. Yeah. Okay, cool. Let's see what part 2 is. During the second go, no go poll, the elf in charge of the rocket equation double checker stops the launch sequence. Apparently, you forgot to include additional fuel for the fuel you just added. Oh, yeah. You have to have fuel to carry the fuel. Welcome to rocketry. Fuel itself requires fuel just like a module. Take its mass, divide by 3, round down, and subtract 2. However, that fuel also requires fuel, and that fuel requires fuel, and so on. Any mass that would require negative fuel. What? No mass should require negative. Should be treated as if it requires 0 fuel. This is a fishy sentence. The remaining mass of any is instead handled by wishing really hard, which has no mass and is outside the scope of this calculation. No mass would require negative fuel. I'm confused. Oh, because you're subtracting 2. Right?
Yeah, so it might go to negative.
So let's do 5. 5 divided by 3 rounded down is 1, right?
Minus 2.
Minus 2 is 9. Yeah, negative 1 fuel for a mass of 5. Okay, so that's what it's saying. So I have to floor it at 0. Wishing really hard. That's cute. The remaining mass is handled by wishing really hard, which has no mass. Okay, so for each module mass, calculate the fuel and add it to the total. Yes. Then treat the fuel amount you just calculated as the input mass and repeat the process. That's recursion. Immediately, that's recursion, right? Continuing until a fuel requirement is 0 or negative. For example, a module of mass 14 equals 2 fuel. The fuel requires... I'm glad I made a calculate fuel function, honestly. the fuel requires no further fuel. 2 divided by 3 and rounded down to 0, which would just call for negative fuel. So the total fuel required is still just 2. That's the end condition of the recursion. At first, a module of mass 1969 requires 654. Then that requires 216, which requires 70. Wow. This is a series. Oh, that's fun. Some of the fuel requirements. Okay, so I've still got my samples, and we're going to change this. So this is I should rename calculate fuel to calculate fuel part 1. There. And we're going to do this. We're going to make our output have like this. This is my part 1 output. There. And now we're going to do a part 2 output. Great. Okay, that runs. So let's make a new function. Fun calculate fuel part 2, which is going to take, it's just going to take mass. It still just needs a number in, right? Returns a number. Now this one is going to have to get us a local variable. So I'll use do, and var base fuel is whatever calculate fuel part 1 gives me for the mass, right? So that gets me this part, right? And then I have to see if that needs some fuel. Now we're going to have to change our function. Actually, I could leave the first one to just calculate fuel without part 1. Good enough. There we go. So calculate fuel of mass, and I'm going to make this one. I wonder if it's going to change the number. Let me put it back to sample text. Because if we add, actually, okay, so the negative thing is only in part 2. So I really don't want to modify this one to deal with the negative thing. I want to leave that by itself, right? So we need to deal with the wishing really hard thing. So var adjusted fuel is if base fuel less than 0, 0, right? I'm just going to floor it out. If it's less than 0, it's just 0. Yeah, good. Else adjusted fuel. Oops, base fuel. Now I've got it floored at 0, right? And so then it would be, I hope it's, how big are my numbers? I got to look. How will I look? I'm going to comment this out. So I don't want to look and give away my input. So what I'm going to do instead is just do max of my modules.mass. I want to see what my biggest one is, basically. Let's see what I get. All right, 149. So I still think that's a log n complexity, right? If I divide by, how many divide by 3s is that? It's whatever power of 3 it is. So the DataWeave stack is pretty limited. I think you only go 256. So as long as it's not 3 to the 256, which it's not, I think we can just recurse without any protection. Otherwise, I would have to use tail recursion. And I don't think they're going to make me use tail recursion on day 1 anyway. Sometimes I'll just trust the problem. So we're just going to recurse and hope that we don't run out of stack. Basically, we're going to have to recurse for every divide by 3, right? So that's the trouble there. So that's my biggest mass in my sample data. I mean, in my input data. Let's put this back. I've got my adjusted fuel. So if, actually, let me put it another way. I'm not going to do adjusted fuel like that. I'm going to do it a more recursive way. So like this. If base fuel is less than 0, I'm just going to return 0. All right. Else, I have to do the recursion. So instead of returning 0, I have to return base fuel plus recurse, right? With on the base fuel number, right? Now, does that make sense? Philip, RJ, you buy that? A recursion, you have to make sure you buy it because I can log, but I'm going to take the base fuel plus whatever we're calculating for the base fuel number.
Then use that as
And then it'll go around again.
well.
Right?
Yeah.
Mm-hmm. Right? I think that's it. I think that's the solution to the whole thing. Let's find out though. So what I'm just going to do is map at first instead of doing. Oh, wait a minute. I forgot to turn this off. Is it? I'm happy. In my machine, I had to go turn off GitHub Copilot because it was trying to answer my puzzles for me. It looks like on this machine, I don't have GitHub Copilot, but I'm warning you, if you have GitHub Copilot, it's going to ruin your day because it's going to solve the puzzles for you and you won't have any fun. So you won't get to do what we're doing. Turn it off. I had to do that on mine. Here, I'll show you how to do that. I left mine on my copy. So I could show you how to turn it off. I think you showed me how to do this, Philip. So you go in your extensions and you find GitHub Copilot chat and you disable it. Because if you do the snooze down here, it doesn't work. Right? So, yeah. Anyway, that wasn't a problem. I was just noticing, hey, I'm not getting suggestions, which I was happy about. All right. So let's take the modules, map, module. Module plus new fuel is going to be calculate fuel part 2 for module.mass, right? So let's go through all the modules and attach a new fuel number to them and see what we get. Oh, I called the function, plus, my bad. I have to append objects. There we go. So 12 gives me 2, 14 gives me 2, 1969 gives me 966, and 100,756 gives me 50,346. Let's see what we get. Hey, 50,346 looks familiar. 2,346, 966. How about 2? It doesn't even do, it just starts with 14. It doesn't even do 12. Okay, I think I got it, right? So I can just take this whole thing. But basically, part 2 is the same as part 1. Sum part 2 modules dot fuel required default 0. There we go. I don't have a part 2 modules yet. So var part 2 modules is modules map. I just wrote this code, but I'll do it again. Fuel required is calculate fuel part 2 module.mass. Save, run, and I get a lot longer runtime. It's crunching. It's taking a long time to recurse. Do I buy that? What I usually do when I'm not sure, here's one way to do it. So the one issue I have with DataWeave Preview is it doesn't tell you that it's running. My CPU is not at max. Maybe it didn't run. Oh, it didn't run. That was actually fast, 51,316. So then let's do that for my actual input. Run. Okay, got a new number. It's actually not that much higher. Wonder, yeah. Well, you guys think it's gonna work? Here we go. Put it in. Boom. Another gold star. Hey guys, day 1 is done from 2019. All right, back to the calendar. Let's go for day 2. So going for day 2, what I would normally do, I'd get up that night. I would save this whole thing. This is already in GitHub by now without my input, right? And I still have that other window up, I think, right? Yeah, so I'll go back to the other window. I'll close day 1. And we'll make a new one. DataWeave, create a new library project. Quest.integration, DAO2. DAO2. You get fast at it. And sometimes you mistype the directory and then you have to clean up a mess. But Advent of Code 2019, and you don't have to put the DAO2 at the end because it does that for you. And yes, I do want to open it in a new window. Here we go. And this time we're going to make sure to put the files in source main resources, sample.txt, input.txt, .getignore, and that's going to have input.txt in it. And then under test, my mapping, I'll delete the my module thing again, get rid of this, put a 0, and we are ready for day 2. That's all it takes to get set up. All right, let's take a look at day 2. 1202 program alarm on the way to your gravity assist around the moon. And these are links, so you can like get curious and click on them and see what they are. This is such a I'd really need to give this guy credit. Eric Wassel. You can follow him. He makes all these puzzles. He every year he takes his time to make all these nice puzzles. Anyway, so thank you, Eric Wassel, for this nice puzzle and all these nice little links in them. Your ship computer beeps angrily about a 1202 program alarm, which is sometimes a link to another puzzle, but this time it's an Apollo 11 reference. Yeah. On the radio, an elf is already explaining how to handle the situation. Don't worry, that's perfectly normal. The ship computer bursts into flames. Okay. You notice the elves, you notify the elves that the computer's magic smoke seems to escape. Do you guys know what magic smoke is? I heard about magic smoke first time when I was 16, no kidding. And I made some. I held a soldering iron on the wrong part of a circuit board and a little smoke came out of a chip. That was it. That's the magic smoke. Now it doesn't work anymore because it lost its magic smoke. That computer ran int code programs like the gravity assist program it was working on. Surely there are enough spare parts there to build a new int code computer. An int code program is a list of integers separated by commas, like this. To run one, start by looking at the first integer in position 0. Here you will find an opcode, 1, 2, or 99. The opcode indicates what to do. For example, 99 means the program is finished and should immediately halt. Encountering an unknown opcode means something went wrong. There was a bunch of programs like this in the other years where you have to kind of make a little program interpreter. This is going to be fun. DataWeave's good at it. It's fine. Opcode 1 adds together numbers read from 2 positions and stores the result in a 3rd position. Great spot for a lambda, right? The 3 integers immediately after the opcode tell you these 3 positions. The first 2 indicate the positions from which you should read the input values, and the 3rd indicates the position at which the output should be stored. Okay, so we have an add opcode that takes each numbers and puts them in other places. So we're going to keep modifying an array of integers as we go. For example, if your int code computer encounters 1, 10, 20, 20, it should read the values at position. So 1 means add. 10 and 20 mean the positions we're going to read the values from. Add those values and then overwrite the value at position 30 with their sum. Interesting. This is too short. So this one would have to have way more numbers so that it would have a position 10 and a position 20 and a position 30. But you're changing the array itself. You're putting a new value at position 30 with whatever's in position 10 and position 20 added up. Opcode 2 is multiply. Same thing, though. 3 integers, right? And then 99 ends. Once you're done processing an opcode, move to the next one by stepping forward. Ooh, there's an interesting piece. You step forward 4 positions, which makes sense if you're taking an opcode and 3 arguments. The next position would be the next opcode, right? For example, suppose you have the following program. Sample input. Let me go put it in the program. Sample paste. I now have my sample input. Keep hitting the wrong button there. Close this. But we have sample input. Cool. For the purpose of illustration, here's the same program split into multiple lines. Yeah. So there's groups of 4. So add, multiply, 99, 30, 40, 50. The first 4 integers are at position 0, 1, 2, and 3. Together they represent the first opcode of addition. 9 and 10. Positions 9 and 10. Yeah, right? And the position of the output 3. Ooh, so we're going to put whatever the output is here. This is fun. To handle this opcode, you first need to get the values at the input positions. Position 9 contains 30. Okay. Add them together to get 70 and store it at output position 3 right there. So the program updates itself. This is cool. Afterward, the program looks like this. Step forward 4 positions. We're going to go here. Reach the next opcode 2. This opcode works just like the previous, but it multiplies instead of adding. The inputs are at positions 3 and 11, which is the one we just did, right? Plus times 50, right? And then multiplying these is 3,500. These get stored at position 0. Stepping forward 4 more positions arrives at opcode 99, halting the program. So these are the steps. Once you have a working computer, the first step is to restore the gravity assist system, which is your puzzle input. Great. To the 1202 program alarm state it had just before the last computer caught fire. Do this before running the program. Replace position 1 with the value 12 and replace position 2 with the value 2. What value is left at position 0 after the program halts? So I'm going to have to run the number, but I'm going to have to make 2 changes. Replace position 1 with 12 and replace position 2 with 2. Okay, that's fine. First, I got to read my input, though. Simple, simple. I'll do the same thing I did last time. Take the input off my screen. Oh, see, it would have printed the whole input. I can see it all. So that's bad. And then I'll close that. Put this back screen and go stick that in my input. Save, close. There we go. All right, we've now got our input, but we're going to start by actually just parsing the program. Let's see if we can run and get the 3,500, right? That's probably a good start. So we're going to need int codes, and I'm going to go back to my, I forgot to grab my actual useful stuff from the last day, right? We're going to go get this bit and use that for the next day. Why not, right? Where's the other window? There we go. So we've now got our input text, except I want sample. And we're going to have to do some parsing. So this is not going to be lines at this point. We're not going to need lines. We're going to need to just split it by numbers, right? So we can just do input data split by comma and take that and map it as number. So now I got all my numbers. There we go. Cool. And I suppose what we need for this problem is we need to be able to read and this is a program. So I'm actually going to make a custom type here. Type int code. Is it lowercase c? Int code lowercase c, yeah. Int code program is equal to array of number. So it's not even, it's still just an array of number, but now it's a special input code. It's a type that means an array of number. And I can do initial program is that. Now it doesn't like that. Map this as number. Why is it any? Oh. I'll just do it in steps. I have to satisfy the type system. So var Tokens is equal to split by stuff. And then let's try that. At least I can break it into 2 steps. All right, see if it, oh, it likes that. It doesn't like that. It doesn't like the first step, right? Expecting type multiple valid coercion functions is at the bottom. Yeah, and so what I can do is just start labeling types. This is an array of string, right? Does it like that? It doesn't like that. Expecting array of string, but got any. Okay, whatever. I'll just make it as an array of string. That I can coerce. There we go. Run. Okay, I'm still here with my initial program. So now we can make functions that do things to a program. I'm gonna have to do the adds and the multiplies differently, right? So there's 3 end conditions. One, so the opcode is going to be the first, whatever position it is. So we're going to need like a function that says apply or execute. What does it use in the problem? Just says opcodes. To run one. Okay, so I'll call it run. Run opcode takes a program, which is an int code program, and a position, right? Which is a number. And it returns an int code program because it's, right, it's just going to make a new one. All right. There we go. How are we doing on time? Probably this will be, part 1 might be the end of it, but we'll see. So we need to recognize what the opcode is. And what if it's not? I guess I'll just treat everything like 99, right? 1 has a thing it does. 2 has a thing it does. It doesn't say what to do if you get something that's not 99, right? Encountering an unknown opcode means something went wrong. It says it right there. So something went wrong. I'll actually fail then. I'll actually do that. So we're going to do a match statement then. I misspelled position. Yeah. So actually, let's do a couple of something went wrongs. If position is too big, right? Greater than equal size of program, then fail. Position too big. Else do. So that protects me from the position being crazy, right? And then I can get the opcode. So var opcode is equal to program square bracket position. Now I have the opcode, right? And then we can do a match. So opcode match. Case 1. I'm just going to return the program in all cases here to get till I'm done, right? Case 2, case 99, and default, or I think it's called else. Fail. Unknown opcode. Dollar opcode in position. Dollar position. All right. Why didn't this? It doesn't like that. What's it mad about? Invalid input /n. Oh, did I not terminate? If position is great. Oh, my F is not terminated. That's better. No, it doesn't like fail. Okay, that I can do. Import fail from DW runtime. There we go. Now I have it. Have I spelled position right? I kept missing the I. All right. So I have a basic run opcode skeleton. So now I can run the opcode and get a program back from running an opcode. We could start with just run opcode on the program 0 and just we should just get the program back, and everything at least is going to run. Okay, I got the same program back, but that's not the right program. So if we have a 1, we need to function add. I'll probably do it that way. Add, and I'll have it operate on a program again. Int code program. They're called add-ins. Add-in 1 position. Add-in 2 position. And destination position. Those are the 3 things, right? Is equal to. So now I'm going to take the program. I'm going to take add-in 1, add-in 2, and add them. And this sounds like a pretty basic DataWeave, right? Var add-in 1. And if it ever goes over the whole program, it's going to fail bad anyway. So I'm going to skip the error protection here. It's equal to program add-in 1 position, right? Var add-in 2 is program add-in 2 position. Boop. Good. So all we do now is we add them together and stick them in the destination position, I think, right? Now that's interesting because how do you do that in DataWeave? You can't do sets. I have to make a new array. I'm probably going to have to chop the array up into parts. There's a function for that, though. Let's go look it up. So I can take the array up to the position, and then I can put the value, and I can take the array after the position. That's basically and append them all together. That's basically what I'm thinking. Because you can't set a value. There might be a function to set a value in to replace a value. There's slice. I think slice is what I want. From number until number. Selects the interval index. No, wait a minute. That's it. From less than equal index of array. Yeah. The starting index, ending index. So slice will give me chunks of the array. So I'll take the chunk before where I want to write, and then I'll put the value, and then I'll take the chunk after that, which will be an off by 1 opportunity. So we're going to have to go. Oh, and I'm going to need this as a function for sure. Let's make that, because I'm going to have to do it in multiply, right? So fun, replace value in program, int code program. The position number, and then the new value number, and it returns an int code program. Now I can test this one by itself, which will be nice. So we're going to do var before is equal to import slice. This is the stuff that's harder in DataWeave than other languages, right? Because you could just set a value in another language. So we're going to do slice the program from 0. Now, what does slice do if I give it 0, 0? That'd be a nice playground thing, wouldn't it? Import star from arrays 0, 1 to 20 or 30, and then I'll slice it from 3 to 3. What do I get? Nothing. 3 to 4 gives me just 4. 1 to 1 gives me nothing. 1 to 2 gives me 2. Aha. So it's exclusive of the first bound and it's inclusive of the second bound. Agree? So whatever the from is not included. How about 0 to 2? 0 to 1? No, okay, wait a minute. 0, 0 gives me nothing. 0, 1 gives me 1. Aha, no, I'm the other way around, right? Until is excluded, from is included, right?
Until is included.
Until is not included.
Not included? Okay.
Well, position 2 is 0, 1, 2, right?
Yes.
Here, let me make the numbers actually have their own positions. There we go.
No.
So now 0 is 0. 0 is in position 0. 1 is in position 1. So if I do from 0 to 1, I get only 0. Yeah, so until is exclusive.
That's right.
So we need that. We need that. So slice the program from 0 to the position that we're injecting, right? So this will be position, and it won't include that position, which is good, right? And then var after is equal to slice the program from position plus 1, because we don't want the actual position, to size of program minus 1. Oh, actually, you could just do minus 1. I don't know if minus 1 is going to work. Minus 1 works with array indexes, but let's do this. Nope, it does not work. Size of program minus 1. Save. And then I can just run this. I can run replace value in my initial program. In position 3, we're going to put a 30 and see what we get. Oh, crunch. What did it do?
Line 18 is mad.
Yeah, it sure is. Oh, I just didn't do the actual function. I just defined the two pieces and thought I was done. So before, and then I'm going to append the new value. Right, and then I'm going to take that whole array that results from that, and I'm going to append the entire after. And then I'm going to run that. 30 is in position 3. That worked. Okay, so we have a way to do that part of the problem. We can replace values now, which is nice. We need that because we need it for add, right? So now we can go back to add. We've got the two add-ins, so now we can just replace value program destination position with add-end 1 plus add-end 2, right? And now we've got an add function. And if that's the case, we can then just do add program, and then I need to take program. This is risky for part 2, but I'm not on part 2 yet. I'm going to assume, because the problem has the same requirements for add and multiply. The first 2 are positions, and then the last one is a destination, right? So arg1, arg2, yeah. So var arg1 is always program position plus 1, right? Var arg2 is program position plus 2, right? And var destination is program position plus 3. That's always the case for both of them. So here I can do add. I don't have to do all the math in the case statement, right? Add program arg1, arg2, destination. Save, run. So it put 70. Is that right? Let's go back and look.
That's right.
Is it? Oh, 70. Good. We got that far. Then we need to loop, and we need to step forward 4 positions, and it's got to be some kind of a while loop. So this is where recursion comes in DataWeave, because we can't have while loops. There's no while loops. So we now need to go each time, and then the exit condition is if we hit a 99. So so I can't have a run opcode function that's separate. I'm going to have to be. It's going to have to be run program. So now I'm done. If I hit a 99, I'm done. So this is actually accurate. This is good. I'm happy with this. Done. Right? So if I'm adding, I have to continue the program, right? So after I add them, let me do this. I'll take this whole thing, var after opcode applied is that. So now I've got the program after the opcode's applied, and I blew up if I got the wrong thing. So now I have to do opcode match because I'm going to recurse only on 1s and 2s. So opcode match. I could have done it all together, but it would have been ugly. I'd rather do it like this. Case 1, and I've already failed if I didn't have a 99, so I'm okay with that. So case 1 is going to be run program, and I give it the after opcode as the applied as the program. And now the position is going to be position plus 4, right? And I think that's it. I think that's good. And then I'll do the same thing for case 2, but I don't have multiply yet. So else, I'm just going to return my program, my after opcode applied program, right? So I'm going to need missing multiply. Going to have to add multiply in right there. But man, I'm going to have to make I bet you part 2 becomes tail recursive. It's going to get long. Let's see. Okay, it at least exited. That's fine. So let's do, because this program only has a multiply and an add. So now we need to do the multiply, which should be straightforward, right? Phone multiply program. It's 1211. This is getting close, guys. What are they called? Multiplicans? I don't remember the math vocabulary, or I do. I'll be, if I'm right, I'm proud of myself there because that seems wrong. Factor? How about factor? I don't even care if they're called multiplicans. Factor sounds right to me. Destination, and it returns an int code program. There we go. Var factor 2. There we go. And then replace the value. I knew I was going to need that. Oops. I suppose I should name them the same things. Yeah. And then I multiply them. Factor 1 times factor 2. Ta-da! Done. And then we'll just add it in here. Multiply here. Program. arg1, arg2, destination. So now multiplies will actually get done. That's step 1, right? And then here, case 2, run program. After, you have to do it after they're applied, and add 4 to the position. And see what happens. Run it. Oh, number in null. Why did I get null? Okay, multiply failed. Because factor 2 position came up with a null. So what I want to do is I want to log it. Wait, what position did I send in? I'm just going to log the whole program here. Multiply. And I'll just like this. So it logs the program itself. So this is what gets passed into multiply. 1, 9, 10, 70, 2, 3, 11, 0. 0? Yes. 99, 30, 40. Where'd 50 go? 50's gone. After my add. Oh, I have to do size of program, and my replace value had a big bug. I was chopping the end off the program. 3,500. Look at that. We got 3,500. I think we're gonna go. We're gonna do it. Initial and final states of a few more small programs. Okay. And what's my puzzle input is another program, but let's try this big long one here. Copy. And let's go to our sample. Let's put that one. And let's run it. Coerce string 99 to number. Oh, you have to be careful with text parsing. 30. 30. Let's do this one. I suppose I should just do my input now, but I'm having fun. Did it save? Oh, I didn't get the right input. $98.01. Oh my gosh, we're getting it. All right, let's just rip it. Let's see what happens. Here we go. Input text. And run my program. Oh, I got this. Let's see if it passes. Oh, it's not the right answer. It's too low. Okay. And it's 12:16. So I'm an hour and 15 in. So I don't know why it's too low, but I did my intention for the study group is achieved. So you know how we're going to debug it, right? We're going to take this. I'm probably not doing it on the video, but we're going to take this and we're going to go step by step through my actual input, which I wouldn't do on recording anyway, and see if I agree with the results. And I would maybe go 5 steps, 10 steps, you know. But we've got the basic. We've got the program that runs. I wonder what it is. Because I got all this. This has happened to me a few times. I get all the sample inputs right. And in other languages, it's because I run out, I overflow things. In Java, it's in DataWeave, it's not usually an overflow. Look how long my program is, though. This is all the logs it output because I have that log in multiply. 34,450. So I got to an answer that's too low. Only for my input. Might be, sometimes it's just like an off by 1 at the end. But that's what I'll probably do with it. I'll probably finish this one on my own and put all this on GitHub. So you can see if you go to my GitHub. Here, I'll show you where my GitHub is on the video. And we can put a link in the YouTube description. This is my GitHub. I keep my Advent of Code repos here. There's 2025. So there's going to become an Advent of Code 2019 repo. Usually what I'll do is I'll put a folder for DataWeave. Actually, that's what I'm planning to do. I'll make a DataWeave folder so that if I do solutions in other languages, then they have a place to go. So in 2024, let's look at that one because I did some DataWeave in 2024. I think I did a lot of DataWeave in 2024. It looks like I did them in day folders here, but yeah. So you find like source test DataWeave, and then you'll find, oh, I was doing part 1 and part 2 separate. So yeah. And no input in here. Source main resources. There's my sample text. So yeah. So I'll give you that link. But I need to let RJ wrap this one up. I don't have any more slides. I have one more slide if you want to use the final slide at the end. Advent of Code and DataWeave. There we go. Yeah. So, all right. You want to take back over?
We have homework now. That's great. I like it. We have homework, everybody.
I want to see your solution.
That's right. Get your homework done. Put it in the comment section. I love it. I appreciate having something to keep on working on there. That was great. You did a good job showing everything. Good job. I'm just going to be honest with you. Going into that, I was thinking, all right, I got DataWeave Playground pulled up. I'm going to handle that. No way. That is not a DataWeave Playground thing. You were right. You weren't kidding. That is way beyond the playground. So very cool. Question and answer time. If anybody has any, I always open it up. Finn, I appreciate you joining us. Good to see you. Finn made it, and I'm going to go ahead and wrap this video up. Excellent work, Ryan. Thank you for coming out. Thank you, everyone, for attending.
That was quite the data weave.